Welcome everyone to the first video of a series we are calling Demystifying CE. In this series we want to explain the various procedures, tests and inspections a notified body may carry out to get your craft CE certified in accordance with RCD 2013-53 EU. This first video will explain how we perform an on-site assessment of the noise emitted by a recreational craft and show you how we recently performed this type of assessment in Denmark on a Chaparral 285 SSI. So, as with everything else regarding CE certification, the requirements for noise emissions stem from the Recreational Craft Directive, RCD 2013-53 EU. Specifically, in the case of noise emissions, the requirements are written down in Annex 1, Part C, as shown here. This annex lays down the requirements relating to noise emissions, when an on-site assessment must be conducted, and the specific amount of decibels that craft may emit when in operation. Now, where the RCD lays down the requirements for how many decibels you can emit, it does not lay down a specific test procedure for determining how many decibels a craft actually emits. The specific procedure for how you can test how much noise a craft actually emits is documented in the EU Harmonized Standard ISO 14509-1. This ISO standard describes, in great detail, exactly how a sound test must be performed. This is thus also the standard that we will be focusing on in this video, and the procedure that we will explain today is based on this standard. Whether you need to perform an assessment against this standard is based on two calculations that are laid down in the annex that we saw earlier. These calculations are the fraud number calculation and the power displacement calculation. You can see the formula for both calculations here, and based on the value of both these calculations, when a sound test must be performed, or when you can use the calculation alone. Now, in order to perform a sound test, we first need a recreational craft. Specifically this one. It's a Chaparral 285 SSI that required PCA certification with EMCI Register. The craft was built in 2003. It has a length of 8.31 meters, a beam of 2.8 meters, a draught of 0.89 meters, a maximum speed of 45 knots, and a power rating of 2 engines, each rated at 224 kilowatt. Aside from needing a recreational craft for testing, the ISO 14509-1 also specifies requirements for testing equipment and testing locations. The equipment list is as follows. You need a Class 1 sound meter calibrated within 2 years, a Class 1 sound meter calibrator calibrated within 1 year, a wind meter with an accuracy of 10%, an engine RPM meter with an accuracy of 2%, equipment to mark the course at 25 meters. We will be using a drone for this test, but you can also use buoys. We also recommend tripods to ensure you can easily set up your equipment and keep your hands free. We also recommend recording equipment to document evidence. It is up to the person conducting the test what equipment they need, but we recommend a combination of cameras and paper logbooks. We also recommend you do the test with 2 to 3 people, but this is not a requirement. And of course, you need a suitable location to perform the tests. Let's get back to the ISO 14509-1, as we can see that it describes quite clearly the main requirement that your test site needs to meet, as well as the course that the craft needs to sail. As you can see from this part of the standard, there are clear requirements for the height of the microphone from the waterline and any land that it is placed on, as well as clear requirements relating to the craft's position and angle of pass-by, as well as distance from the microphone. As we can see, we need to get the craft to sail at the correct distance from the microphone, and this is where the drone that we mentioned earlier will come in. More on that later. Now, before we start the test procedure, we need to do the following 4 things. Step 1. Set up and calibrate the sound measurement equipment in accordance with the manufacturer's procedure. Make sure the meter is calibrated correctly and adjust it if necessary. Step 2. Measure the background noise and background conditions and write these down. If the conditions exceed the allowed limits, the test cannot proceed. And remember, you must do this at each pass-by moment as well. Step 3. Check the wave height in the desired testing waters and ensure it does not exceed the allowed limits. Again, if this step fails, you cannot proceed with the test. Like step 2, you must do this at each pass-by moment as well. Step 4. Set up any other required gear and ensure the craft gets into position to get started. Now, about step 4. In order to mark the course at 25 meters, you can either use buoys, which take a long time to set up and require much more equipment to bring to the test site, or, as EMCI Register has decided to do, you can use drones. Specifically for this test, we're using the DJI Mavic Mini. So, about the drone. It's highly portable, fast, can handle more than the allowed maximum wind speed specified in ISO 14509-1, and it has many high-quality apps supporting it that allow a high degree of data recording and reporting of results. The Mavic Mini is controlled via your phone through a dedicated controller. As you can see by this recording, taken during our test in Denmark, the drone is flown out to 25 meters, indicated by the distance marking in the lower left corner, which updates in real time. The drone also sends a live video to the operator, allowing them to see what is happening around the drone. The other thing that we can note is that, over the course of the recording, the drone holds a position at 25 meters for the duration of the test. The time it takes to get started with the test is significantly reduced because the drone is up in the air in the matter of minutes. So, now that we have set up all the equipment and followed the setup procedure, let's get started. This first camera view records the passage of the craft from the point of view of the microphone operator. We can see the craft passing perpendicular to the microphone and under the drone, thus following the required course. So what did we measure? Well, when sailing by at about 70 kilometers an hour, the craft's engines revved until 4,000 RPM. The measured wind speed was 2 meters per second, the background noise was 55 decibels, and the craft's sound emissions was around 72 decibels. Now, let's have a look from the drone point of view. You can see the drone operator adjust the camera on its axis slightly before the craft approaches. The craft adjusts its course for the drone, and once it passes the microphone safely, steers away from the mouth of the harbor and begins to slow down. This extra camera view is a great additional reporting tool for a notified body to be able to verify test results and test integrity. So how did the chaparral do for the entirety of the test? We already saw what we recorded for a single pass by earlier. For the entire test, we measured the following. Wind speed never got above 2 meters per second. The craft always passed by the microphone at 70 kilometers an hour. The engines always revved at around 4,000 RPM. The maximum background noise was 55.6 decibels. And the maximum measured sound emissions was 72.38 decibels. The RCD limit for noise emissions for this craft is 75 decibels. So this craft passed the noise emissions test and, as long as it meets all the other RCD essential safety requirements, can be certified. Now, the last thing we need to do for a sound test is to correctly and accurately report the results so that supervisors and stakeholders can verify the test. In order to do this, we use the format provided by ISO 14509-1 Annex B. Now, we're going to slowly scroll through the document, and you can see that most of the required reporting is quite self-explanatory. First, we can see that we need to document some general information about the test, the used equipment, and the test site. It is smart to document this during the 4 preparation steps we discussed earlier and, as far as possible, before the test even begins remotely. Next is information on the engine and craft. This information is quite technical, and you should ask the responsible manufacturer or person placing the product on the market for this information, if you do not have it already. After this, we see the ISO 14509-1 provides a table for documenting the sound test results. It lists all information that you must collect each time the craft passes by the microphone. Based on the information in the table, you come to an average sound emission in decibels for each side of the craft and the maximum sound emissions. After this, you can sign the document digitally using a tool like Adobe Sign, and the reporting will be completed.